Hi and welcome. It's Pearson, the science teacher. So look, another simple question here. And this question falls under ideal gas laws. And we have a lesson uh, right in our collection of videos that pertains to this lesson here. So if you want to check it out, it's under gas laws, and that's thermodynamics lecture 1.1. Just feel free to go and check it now, or you can even still start from here and still go back and check it. So let's go straight into what we have on the table today. A cyclist observed that the pressure in the rear tire of his bicycle was low and decided to inflate it using a bicycle pump as shown in this figure, that diagram there. So the air inside the pump is initially at a pressure of 80 kilopascal. Okay, during a single stroke of the pump, the volume of air in the pump is reduced from 110 centimeter cubic to 10 centimeter cubic. Okay, A. If the temperature of the air remains constant. That is a very good point. So if the temperature is kept constant, you already know we are dealing with Boyle's law. Okay, what are we calculating? Calculate the pressure of the compressed air in the pump. All right, simple question. So we see from this question that our pressure, the initial pressure, is 80 kilopascal. Our initial volume is 110 centimeter cubic, and we know that our final volume is 10 centimeter cubic. So what we're looking for here is the second pressure, the final pressure. All right. So having identified that this is Boyle's law, we are just going to apply the formula. And we know that the formula is going to be pressure 1, volume 1 is equal to pressure 2 and volume 2. Okay. So pressure 1 is going to be 80 kilopascal. Pressure 2, we don't know. All right. Then volume 1, we know that it's 110 centimeter cubic. Then volume 2, we know that it's 10 centimeter cubic. Let us remember what Boyle's law states. Boyle's law states that at constant temperature, the pressure of the fixed mass of a given gas is directly proportional to its volume. So what this means is that since the volume was reduced from this to this 10, it means the pressure is going to increase from this to something, it's going to reduce from this to something even greater. All right. So since volume was reduced, the pressure is going to be increased. If pressure is increased, the volume reduces. So that is that. So let's go into calculations and see what we get. Let's bear in mind this data here that we're given. So we're saying pressure 1 V1 is equal to pressure 2 and V2. We know that pressure 1 is 80. Kindly allow me to deal with my video here to create more space. So we know that we're going to have 80 kilopascal multiplied by, multiplied by 110 centimeter cubic is equal to P2, what we're looking for, multiplied by 10 centimeter cubic. All right. So since we have this, what we just have to do is divide both sides by 10 centimeter cubic, and even this side 10 centimeter cubic, and we know that this and this will get to cancel. We remain with P2. Our P2 is simply going to be 80 kilopascal multiplied by 110 centimeter cubic over 10. And before we go any further, we know that these are going to deal with each other, and we are going to remain with only this unit as what pressure is going to carry. All right, so to go further, what we are saying is, what we are going to have is, having made pressure 2 subject of a formula, we are going to have 80, of course, kilopascal multiplied by 110 centimeter cubic over 10. Just repeating that expression there, so that we know that the two are being multiplied. And when the two multiply, we are going to have pressure 2 is equal to 8,800. That's what we are going to have, 8,800, using kilopascal, using the calculator here, over 10. All right, so this 10, remember I've already dealt with the centimeters that was here and here, so that's why it's like this. So 10 into this number, we're just dealing with a 0, we're just removing 1 0 there. So pressure 2, we learned that is equal to 880 kilopascal. Now the question is, if you analyze this question, this answer that we are getting here, is it making sense? Does it really obey the Bohr's law? All right, so if we want to know or really justify in that way, we are going to analyze this. So pressure 1 was 80 kilopascal. Pressure 2 gave us 880 kilopascal. This is 0. All right, then V1 was 110 centimeter cubic, and V2 is 10 centimeter cubic. So when the pressure was 80 kilopascal, these were the volumes. All right, so when the pressure was increased from 80 to 800, we expected the volume to reduce. All right, so since the volume was reduced, what I'm trying to say is, since the volume was reduced, hence the pressure increased, because that's what Bohr's law states. All right, so thank you very much. I hope you followed. Please feel free to go through just all the videos and find the one that is most useful to you, and get to use it. Let's learn together.